Good morning. I wanted to start off the video today talking about a pair of E300 Kaspa mining FPGAs that I ordered from Osprey Electronics. And basically you can see right there, that's Osprey Electronics. They provide these E300s ordered. They come shipped out of Texas. They have a standard profile for a lot of the smaller ASIC styles where they have the intake fan and exhaust fan on opposite sides like that. And they're set up to run with three mining boards in each one. They have data connectors for each one, and they initially come shipped with no cards installed, no hash boards installed. So what we have here is just the frame. It houses the electronics, which controls the hash boards up top, and an Ethernet connection. And I don't know if that shows or not. Basically, you have your reset, reload Ethernet ports, as well as the two fan connectors up front and the data connectors off the back, which plug into the FPGA modules. So I'm going to go ahead and get the hash boards installed in this, get them fired up, and see how they look. All right, the hash boards themselves come well packed, a lot of foam protection around them, and you get 3 in the box to go, 1 for each miner. They're vacuum sealed and well packaged. Let me pop one out and take a look at it. Okay, as you can see, these hash boards are very large. They've got a very, very large heatsink on the front side, which I believe is aluminum. I mean, it could be stainless steel, but it looks to be aluminum. It's fairly heavy. And looking at the back side of the board, the ASIC is on the underneath up against the heatsink. And we have a lot of voltage controllers, VRMs on the back side here, along with 2 power connectors and a data connector. The boards themselves come in 2 different widths, I've noticed. They have a wider board, and then they also have a narrower board. And if you put them, next to each other where you can get an idea of the size, let's do this. You can see there's a narrow and a wider version. And the reason for that is how they get inserted into the box itself. I'll go ahead and do a sample of that. Sorry, I don't have a camera stabilizer or anything. I'm just using my cell phone. But basically, the way you do the installation is by removing the 4 screws that connect the fan to the case itself. And then underneath it, underneath the fan, there's another little back plate here that you can see these little 4 screws tacked in on the corner. You remove those. You can pull the fan and this little back plate out, and then the cards slide in individually into each of these slots. All right, so with the fan and cover off, you can see in the back side, there's nothing in there except the fan at the other end. So basically, the way you do this is you take one of these boards and you just drop it straight down into the grooves, and so it'll slide right in like this, and it will go right down just like that. And as you can see why they have the 2 different widths, the board on the outside here, if you try and put this one in this slot, it won't fit. You basically have to put the narrow one here, the thicker one here, and another thick one right here. And then you can hook up the data cables to the top side, to the data ports. They basically go right in there. And then you have 2 power connectors on each board, so you got a total of 6 power connectors, and then 1 over here for 7. And that can be powered off a standard server PSU with a breakout board. In order to find these FPGA miners for mining Kaspa, you can actually order them directly from Osprey Electronics at their website shown here. The E300 is made up of 3 Xilinx VU35P FPGA modules that are installed in one miner. You can purchase it from here. It's approximately $6,000, I believe, at the time of recording. And next we will go into more detail about the miner itself. Once you have your miner configured, your FPGA configured and up and online, you can log into it. It has a default login of root and password. You then get to the FPGA status page, which is this one right here. What I noted was that I had a little difficulty initially in getting these to power on and run, but basically if you set the VCC INT to 635, which is in the voltage settings section down there near the bottom, you set that to 635 and the miner will actually start up and run pretty well at that point. Let me take you through a couple of other tabs in this. When you go into the miner configuration by hitting the miner link on the left side, it takes you into this page. This is where you actually set up the mining algorithm, the Team Red miner. You set up whether you want auto start, the algo you're going to hit, your pool, your wallet information, your worker ID, which is basically just a name. It's the same thing that you see in Hive OS. For the FPGA core clocks, we set 620. And for the HBM clock, I'm using 900, although I'm told that that's not an important setting by Osprey. But I went ahead and set that anyway, as I saw it recommended in some other videos. Now, if you take a look at the miner logs, you can actually see the process of it hashing directly. That did not work. All right, so basically you can see it hashing. We're getting accepted shares on the Woolly Pulley pool, and each board, as you can see right here, is running at approximately 4.9 gigahash for a total of 14.8 gigahash at the pool side. Or the pool is actually reporting 13.1, the miner's reporting 14.8. Now, if we take a look at the Woolly Pulley pool itself and take a look at the Kaspa wallet that I'm mining to, you can see on this page that currently I have 25.38 gigahash being reported at the pool side, and I've been running for a few hours now. I have two of these workers, so I have E300-1 and E300-2 down below. They're showing is 13.4 and 11.9. So basically, what I'm seeing is a return right now of about 70 cents in 60 minutes. And if you take that 70 cents and multiply it by 24 hours, you get approximately $16.8 dollars for both miners. And if I cut that in half, that's about $8, a little over $8 per day for each one of these miners. Now, given that these miners are running just under 500 watts of power, you get great efficiency. Let me show you some of the mining efficiency now. Now, if we go to MinerStat and go into the Kaspa mining calculator, and for one of these miners, I'm putting in 14800, which is just over 28 gigahash for both miners, but I'm putting in individually. So each miner right now is generating about 14800, and the power is 459. They're advertising just under 500 watts, and I'm definitely getting that at the wall. I put a power meter on it so I can measure and see what I'm doing. I put in my electric rate of 10 cents per kilowatt hour, which is been under discussion several times as to whether that's accurate or not, but at least that's approximately what I'm paying. So again, for the last 24 hours, you can see on a per rig basis, or a per ASIC miner, FPGA miner basis, that I'm getting about $7.30 estimated profit on an electricity usage of $1.10. So if you think about that, compare it to some GPUs, you're going to see that with GPUs like a 3070 or something like that, you're going to, for Kaspa, probably get around roughly 10 cents in a 24-hour period for running that after the electric payment. Whereas here, just on this alone, I'm getting $7.30 some odd cents. So with the low comparative electricity use, this appears to be a lot more efficient than running off GPUs for Kaspa. So yeah, I hope you liked the video, and I'm going to close it out at this point, and we'll talk to you guys later. Bye.